Hi all, welcome back. This is Balakrishnan and I'm here to explain my project that is CatchDup, which is a semantic duplicate detection application. It is an ML and NLP based project. Now let's start. So what is the project is all about? So you will be given a pair of questions. You need to say whether those two are meaning the same or not. Okay, so that is the overall goal. So the data set that we are going to use is for our question pairs, and these are the details about it. So this is the sample screenshot which I have placed. So question 1 ID, question 2 ID will be there, and then question 1 and question 2 will be there, and this is the target column that will be 1 or 0. Okay, so this is not a simple string matching problem. Like to explain it, I have taken two set of examples. So if you see here, right, what do you mean by plus plus in I plus plus? What do you mean by I7? These two things are having a lot of words in common, but still they are not the same questions. These are not duplicate questions. Whereas if you see these two questions, right, can Donald Trump still win the elections? Does Trump has the chance to make a win in the US presidential election? These two questions are looking so different, but they are a duplicate. Okay, so it's not a simple string matching problem. So what is our goal? Our goal is to build an ML model to solve this issue. So the EDA I have performed to understand the data, the distribution of duplicate and non-duplicate, and number of repeated questions, all these things I have done in order to understand the data. And then we have used bag of words approach, that is via the count vectorizer. What is it all about means? It is an NLP technique that is used to convert the text into numerical features. Okay, what it does means, against every word, what is the frequency of every word in the document? It just searches and then it makes a matrix. It makes a vector kind of thing. Okay, so for the entire data set, it makes a matrix. So if you see this, right, count vectorizer is available in scikit-learn, okay, which uses the bag of words approach. Okay, it performs tokenization, vocabulary building, and then word counting in a single step. So what is the flow means? First of all, I will do just apply bag of words plain, then with basic features, then with advanced features and pre-processing. Then out of this, which is the best, I will convert into the pickle file and then build the Streamlit web app. So what are the pre-processing that I'm going to do is that I will be replacing certain special characters, then numbers with equivalent strings, then decontraction of words like rint will be like rint, and then removing of HTML tags, punctuations, and then like I will remove stop words too. Okay, so instead of just not wasting time, I will just directly go into this advanced features and pre-processing step which I have done. So these are the 6 token features that I've used, and then 3 length-based features. Okay, I'll explain all these things in a moment. Please hold with me. So if you see this, right, this is like mean length, absolute length difference, longest substring ratio, and then we'll also be using 4 fuzzy features using this fuzzy library. So I'll tell what it is all about. So in the string, right, Sachin is a great batsman. There are 5 tokens, 3 words, 2 stop words. Okay, so CWC means is common words divided by minimum, common stop words divided by minimum. CSC, CTC means it's token, common tokens divided by minimum. So it can be minimum also and then maximum also. And then like common longest common substring is like we all know, right? Like this is the question 1, question 2. Like this is the longest, right, which is matching. Okay, longest common substring. So these are the graphs. Okay, proving that there is a differentiation, right? Like you can see, right? Like if suppose my value stays from here to here, then it is 0. From here to here means it is 1. So like here with these graphs, I am trying to prove that my whatever the extra feature engineering that I have done is actually useful. Okay, this is for max ones. This is the length-based features. And these are the fuzzy features. So this is the TSN graph, which proves that our model is able to differentiate, how well our model is able to differentiate between 0 and 1. So now I'll come to the main point. That is the machine learning model that I have used. So I have used random forest, which is an ensemble learning algorithm. What it does is that it uses multiple decision trees. Okay, it is used for regression and classification also, but we are here using for classification. Okay, what we are going to do is that, see, what it does is that it has multiple decision trees. All the decision trees are like trained with a subset of data and then a subset of features. Okay, these two are like it is like trained with that. Okay, the main purpose is that the randomness. Okay, the randomness here prevents the overfitting and then gives us more performance by generalizing. Okay, because decision tree, right? It is the biggest con of it is overfitting. It overfits with the training data. In order to like avoid that, only we go for this elevated version, which is the random forest, which uses an ensemble technique. This is an ensemble learning algorithm basically. So this is the result checking. Like here, if you see means like 1 and 2, right? It's Indonesia and India, but it says it's false. Like it is correct. So here the wordings are like bit changed, but still it stays it's 1. So from this, like our model is very good at predicting, because these questions, right? These questions are not in the data set actually. Okay, these are actually not in our data set, but still these questions are being correctly answered by our model. Okay, so I'll come to the performance metrics of all the 3 ways which we have done, like 73, 76, 79, which is like increasing, which is good because like more advanced features and more pre-processing we have done, our accuracy is increasing. And then we can see the F1 score is also being increasing. So definitely like this is the best model. We will pick this and then we will use it further. So what is the overall flow? Question data was that for our question pairs, and then we pre-processed it. We used bag of words feature, and then we used the technique, and then we did feature engineering, and then we tried various models with hyperparameter tuning. We selected the best model, best for hyperparameters, and then we created a pickle file out of it, and then we are using that to build the Streamlit web application. So this is the overall flow. Thank you for your valuable time. Let's have a live demo now. Right now, we will use this particular example for that. So if you take like this thing, right? So this is my website. So it's a simple website that I have converted for simple purpose. So now it says not duplicate, exactly. So now we can try for this. It should say duplicate in the ideal case. Let's see. Okay, because these questions are actually not there in the data set, actually, the training data set, but still, yeah, it is duplicate, exactly. So it is exactly detecting it, like it is working very well, the random forest model. So this is my GitHub repo. Hope you all liked it. Thank you very much. Bye.